All right. Well, welcome everybody back to the Anarchist Project. Tonight I'm going to be working some more on this MIDI controller that we're building, and we're going to be designing the circuit board. So it should be pretty straightforward. I've never actually used this software though, to lay out a circuit board, so I will have to learn some stuff. But that shouldn't be too bad. But yeah, feel free to hang out and chat and uh, give me any tips or feedback that you think, and we will get this thing done. All right, let's go to work. So first things first, I noticed something based on how I was already doing this. Let me bring this up, not this screen, but this one. Okay, here's the data sheet for the potentiometer. I ordered this one, the audio taper one. For some reason I thought I had ordered the linear one, but I didn't. So we're working with this audio taper one. And you'll notice that it's ideally on the low end, supposed to increase slowly and then change drastically on the high end. And if you've been watching any of my previous streams, you'll know that that's actually the opposite behavior of what's been going on the way we have it set up. So I actually have this thing set up backwards. So we need to fix that in the circuit, and then we need to fix that on our circuit board, because if I pull this up, these sliders, R1, R2, and R3, are actually upside down. So we're going to have to redo our math, figure out how to flip these around, and keep them in the right place. And yeah. So, kind of annoying, but not too bad. So I'm going to go ahead and change the current goal here. Fix potentiometer. Potentiometer. I think that's how you spell it. Orientation. All right. And actually, I'm going to turn the music back on too. Let me know if the music is too loud or anything, and I will adjust it. I think it might be a little loud, but we'll see. Also, I hope everybody's having a good Tuesday. Feel free to let me know. Mine's gone all right. Okay, so we've established that this is backwards, and that actually we need to have the voltage come in on pin 3 and the ground on pin 1. So that's pretty easy to do. So let's just delete the wires first, actually. Oops. Come on. And then these need to get moved over here. And then we could probably just use one ground for all of these on this side. So delete this one and delete this one. All right. And then connect these. And then connect our ground. Okay. So that should be good. The input is still the same to the controller, so that doesn't change on anything. Alright, so we will save that, and then we need to compile our design. My computer is running really slow today. I think I don't know how the stream health is doing. Seems okay. Windows Update is going to be the death of this channel. I can promise you that. Okay. Let's compile it. Didn't get anything, so that's good. And then we need to get all our changes in here because a bunch of these connections are going to flip around. So import changes, all of these, execute them, looks good. Okay, close. Okay, and then I'm pretty sure we do need to flip these around. So I need to figure out where this is going to go if I rotate it. Come on. R2. I went up here. Just a little bit off the board. Okay, why isn't it moving? I did this last time really easy, and now I'm having trouble. Let's see here. Select. You know what? I made a note the other day of all of the offset measurement. I need to go find that. Here it is. Although all the math on it is wrong now. I can't seem to select this. I don't know what I'm doing wrong. Oh, it's locked. That's why. Whoops. Yeah, okay. That makes sense. Alright, where is the... There it is. It's up there. Okay, so where is the best place to put this? Oh man, I did all of that math the other day, and now I'm going to have to redo it all because I messed up and did this backwards, upside down. That's going to make this really hard. Okay. Let's just go ahead and flip it. So 90 degrees, that puts that way up there. And then let's just move it down and figure it out. All right. So that's right there. So we need to, this is the part where I need to go through and figure out where the center is again for this whole thing. Oh man, that's really annoying. All right, move this off to the side, but I don't need it. All right, so we're working in Imperial right now, so we're working in mils. 1,007 an inch. And it looks like we're here at 275 Y, and up here we are at 440 Y. I need a calculator again. So basically, I'm going to have to figure out where the center point. Well, actually, no, I don't have to. I just need to figure out where it is in relation to the bottom, because I know I wanted to move it a certain distance up from the bottom. So I need to figure out how much to subtract it by. So 440 minus 275 is negative 165. So wherever we want the bottom of it to be, we need to actually set it 165 mils lower. And then the X seems to be this very middle line right here. So that's 1875. The origin point's there. So that's 2200. So we need to add 325 to the X. I'll save that in my little note here. Okay, so anywhere we want the bottom center of this to be, that's where we gotta put the origin. Now, if we go over to this, and we said we wanted the Y was at 140, so we wanted it to be at 280. So we need to actually put the Y for this particular one at 280 minus 165. Which is just 115? Yeah, 115. Okay, yep, that looks correct. And then the center, the length of this this bottom is 3040, so we need to divide that by 2 and then add 325. So pull this into frame real quick. So 3040 mils divided by 2, add 325, 1845 on the X. Okay, that is the middle. Probably. All right, and then we'll lock that in place. Okay. Now, let's see. All right, so we want to figure out where we want to place these now. Let's go ahead and they need to be flipped, I think, still. Yep. So 90 on that one. 90 on that one. Okay. And then we can go ahead and set the Y for each of them, the Y component, which is at 115. Okay, now we got to figure out the spacing for the X component. That would make sense. Let me look something up real quick. I think I'm going to do some kind of like golden ratio spacing. I was talking about that last time. So basically there's like a ratio of an offset. So I could put this, for example, this one right here, I could put it directly in the middle of the end of the board and this middle slider. Or I could offset it over to the side a little bit. And there's a spacing there that will actually look really good to the human eye. It's called the golden ratio. It's expressed algebraically as the Greek letter phi. It is 1 plus the square root of 5 and all of that divided by 2. Interesting. So the total distance divided by A should equal that. All right, so I got to figure out the formula here. So the magic number is 1.618033. I'm going to go ahead and just type that into my calculator and store it. 0.618033. Okay. And so if we take the total distance and divide by that, okay, that's how that works. So we take the total distance between this middle slider and the edge of the board, we divide by that 1.6 number, and then the result is what should be the distance between this slider and this slider. And I think I do need to reset the Y on this one because I messed with it. Yep, 1.5. So that's what we're going to do. Now we know the total distance between the middle of the slider and the end of the board, since it's in the middle, is 3,040 mils. So we'll take 3,040 divided by this number. Nope. 0.40 divided by... Oh, I didn't actually save it in memory. Sorry. Memory store. Okay. 3040 divided by this value, and we get 1878.8. 0.82. I think we can do that. I wonder if this lets us do decimal increments here. 1878.82. Why did that not work? Because we have to add. Okay. Yeah, we forgot that it was over on this side. So that's like some perfect ratio thing. Total, I don't know. It's not right is what it is. Okay. So let's just go ahead and do 3040 divided by 2. 2. And let's store that. And then that doesn't need to be full screen. Okay. So it should be whatever our final value, we should add to this number as well. Definitely. So we take, at least for this R3 position. Okay. So we take 1520. We divide by our magic number equals this. And then we add that to that. And we get 2,459.41 mils. All right. I hope I moved the right one. I did. Okay. Yeah, because it's locked. All right. So we know this is 115. Whoops. And then this one, 2,459.41. Okay. I think I did that backwards. I think it needs to be on the other side. I solved for the wrong letter. A. So how does that make sense? A divided by B is 1.6. Take A divided by 1.6, I get B. Okay, so I need to take this 0 minus that value. I'm still doing something in my math wrong. If you know what I'm doing wrong with my math, feel free to tell me. Five, 9. Let's see. 2 divided by magic number. Yeah, that's not right. Oh, I didn't add my offset. That might be what's happening here. Hold on. I think I was on the right track. Divided by this plus this, and then add the offset. What is the X offset? 325. 2784.41. I don't know if this still doesn't seem like it's going to get me there, but maybe it will. Okay, it did. So that's correct. So that's like the spacing we want, basically. So when the switches are coming up through the top of the casing, this kind of spacing aesthetically should look pretty good. But we'll be able to model that and see that later. All right, so now I got to do this one, which means doing it kind of the opposite way. So take this value, divide by this, equals this number. We're going to store that. I already did. All right, take that value minus this number, and then add our offset of 325. 905.59. Okay, so that should be pretty evenly spaced there. So now we can lock both of these in place. Okay. So that looks good. And then we need to move these onto the board and get the resistors onto them too. And then we don't have enough room to place this in between two of these sliders. So I think we're gonna have to place it on the underside of the board. Maybe just like right over the middle of that one. I think that could work. I don't know how to flip something to the other side. Designator, component, type standard. Oh, upstairs neighbors making noise again. Does anybody know how the circuit maker how to flip something to the other side of the board? I guess we should check too if it would actually fit, because we're planning on putting it inside this case, and if the we need to check the drawing on that real quick. Need to check how tall the standoffs are. 0.25 inches. I don't know if that'd be enough room or not. I don't know how tall this thing is. I think we're going to have to move it up anyway, so I think we'll be okay, but I genuinely don't know how tall this thing is. Yeah, we'll have to double check that later. I think it'll be fine, but we'll double check it. Oh. One of these views does this. There we go. All right. Now let's go back to this view. So I'm thinking put the teensy way down here on the other side. I need to figure out how to flip this. I would think it'd be in here. There should be like a layer that I can select. Designator comment. Oh, here it is. Top layer, bottom layer. That's what I want. Okay. So now you got to think of it as being upside down. You'll notice the U1 is backwards because it's flipped around. All right. And actually, you know what? Since I just pulled up my streaming window here and I realized that our goal is outdated already, so let's change this to layout the circuit board. Okay, but you notice if I zoom way in here, this U1 is backwards because it's actually upside down. It's underneath. And if I go to the 3D view here, then we can see that. We can see that it has positioned itself so that when I move it, it's going to be underneath the board. And so what we'll do, and that'll allow us to get around the spacing problem of there not being enough space here by just sliding it underneath rather than having it be on top. And you know, if you're familiar at all with circuit boards, you've seen that they had stuff on top and bottom, and that's what we're doing here. There we go. All right. So that being said, I need to move this to like whatever is the equivalent of the center for it. How to do that? I need to figure out where the center is. Oh, it looks like it's a standard. It's on the corner, and it's a pretty standard width. Okay, so if I look at it, got to do this math again. The X. Man, the upstairs neighbors are just like diving off the couches or something. I don't know if y'all can hear them. It's epic. 2250. Minus 1550. So 700 mils across. So we divide that by 2, which gives us 350. So I need to add 350 to our X component to have it in the center. And then height-wise, I can really place it just about wherever I want it. Let's just do 280. Let's put it up here at the very... Or no, we can't do that because these pieces are going to be coming through the board. We really need to put it above anything that's going to be coming through the board. So there is still a risk because these are guide pins right here that are going to be going through. They're... let me see. I'm going to hold it up to the camera here. So these pins, you can see them on the bottom of this thing here, are going through that circuit board, and they're much longer than a circuit board is thick, so they will go all the way through plus some. So we want to make sure that they're not going to be in the way. So yeah, we'll keep our teensy up here. That'll give us enough room to solder everything because we're going to have to solder it all by hand. Sorry, let me pull it back up. So we'll keep it up here, but we need to put it in the center. So the X component should be at 1520 plus 350, 1870. Oh, and it's already at that. I basically guessed it and just happened to put it in the right place. All right, let's lock that. Okay, now we need to figure out where to put all our switch connections and where to put all these resistors. And that shouldn't be too hard. But it could matter a little bit based on where they're plugged into the board. Our board's not that complicated though, so I'm not that worried. Honestly, probably want them in the center. Okay. I don't know if we should keep them vertical or if we should. I think we should rotate them, honestly. Yeah, I'm thinking so. Let's move them all off the board and do one at a time. Whoops. That might make it a little easier to see what's connected to what. Okay, yeah, so one should go first, then two, then three, then four, and maybe they can all like wrap around or something. It shouldn't be that hard. Shouldn't be. And then I'm going to rotate all of these 90 degrees. Wait. Nope, that's not right. It just rotated that one pad. I need to select the part. That's the designator. I can do it. There it is. Perfect. Okay. Apparently I have to click in the very middle. I should have put some marker or something there. Okay. Where was one more? Where'd it go? There it is. Okay, I think this will work. And then I think what we're going to do is basically drop it in here. And then drop number 2 in there. Down a little bit. And then number 3 over here. Should number 3 be down there or up higher? No, 3 should be up there and then 2. So I'm thinking from the standpoint of sometimes you have to move things around. You have to think about like how they're going to be routed. So you eventually have to draw wires connecting everything. And so I'm trying to think ahead to that because that will be important. Yeah. I think that way works out best. Or I might have gotten that backwards, actually. I think I did get it backwards, actually. 2 goes around. 4 needs to go around 3. Yeah, 4 needs to go up. Okay. Now my OCD is going to make me figure out exactly where to put these to land them evenly between. I don't think it's important to get them even. We just need to get them at least lined up because it's going to be underneath. It's going to be hidden inside. Let's just get the spacing all worked out. So I guess we have to decide the spacing then. What is the best way to do that? I think just pick something at random. Yeah, just a quick double check. I'm not totally sure this thing is like in the middle. It is. Interesting. I'm just like double checking a couple things. So I think it's what it is my eyes playing tricks on me. All right. I think in reality, this should be like lined up with the same holes that are up here at the top, just because we're going to want these to be as close to the end because the buttons are going to be up at the top there. I think that makes sense. We'll just pick something, say right there. All right. And then we want this to be lined up with that. So just like that, and pick somewhere right there. And then we basically just want to line it up the same way on the other side. So, but one thing I can go ahead and do is lock this stuff in place. Yep, there it is. Good and good. Okay. And then what's the Y on this? 3250. Okay. So we'll change the Y to, oh, I actually got that. Okay. Got it in the right place. Lock that. And then what's the Y on this one? That was the wrong part. 2750. $27.50. Okay. So that's correct. Just double checking. Okay. Next, we need to do the resistors. We'll move this one off the board because that's number 4. Let's start with, that's number 3. Assume this one's for number 2. Nope, assumed wrong. Number 2. I'm going to flip it sideways. See what this looks like. So I'm watching those lines that say they have to connect and just trying to place them so that they'd be close together. You know, that doesn't leave much spacing between the parts. I may actually want to flip that vertical. How much spacing is that leaving us? 'Between that, 1250, 1350, so 100 mils, so 1/10 of an inch. That's pretty small. I think it gets flipped back vertical, and both of these, switch 1 and switch 3, move down. let's just move them down some amount. Y location is 2750. Let's just do 2400. Where does that put it? I think that looks good. Okay. There we go. And then, right. I think we should rotate it. To 270. Okay, and then we'll move it up here and drop it basically in the middle of this. Let's move it down a little bit, leave some room. Things are not going to be centered, so don't worry if they're not. Yeah, and then I think we dropped the other one right in there. So because this point is right in the center, okay, so let's lock this in place and then use that to decide the others. So for switch 4, that's R7 here. So properties, Y is 2975. Move number 6 out of the way. Wait. Oh, no, it's not rotated yet. My bad. It's like, that's way too high. Okay. And then, what's the X? 1025 minus 1025 equals, so it's 495 distance from the center. Add that to 102, so 2015 is where that should be. Okay, that's more or less like evenly spaced. I know it's not like gonna look totally correct with everything we're doing because we're not trying to, but that at least gets us started. Okay. Then why is that connected there? Because it's a ground, that's why. All right, so this needs to flip again. All right, and then I really just need to place it somewhere and then do the same on the other side. That's probably a good spot right there. So let's lock that into place. As you lay parts out, like you should, it is a good idea to kind of, a lot of what we're having to do is lay them out aesthetically. But in reality, it would be a great idea to lay it out such that there's a minimal amount of these lines that are showing the connections crossing each other, because that means it'll be easier later when you're actually trying to draw the wires to run them around each other and everything. If there's a big nest of wires crossing, it's going to be very hard. Especially because we want to keep our board to 2 layers, a top and a bottom. You can have boards can have like mini layers in the middle, but it's more expensive. Okay, I think I gotta rotate it first, and then Y is 2025. So 270. Then Y is 5. Is that right? That doesn't look right. Oh, it is. Okay. And then where's our X at here? 975. 20 minus 975. 545. And we need to add that to this. 2065. Whoops. Okay. So that should give it some even spacing, and then we will lock that into place. All right, that's locked. Okay, so everything is on the circuit board now. And then I just want to double check this link thing. I'm going to check the distance between the edge of this piece and the board. So 405. And where's this one at? 2635 plus 405 would be, okay, 3040. So that is lined up correctly, it looks like. Now I'm going to go to the 3D view here just to make sure we're not colliding anywhere. Our spacing looks good on just about everything, it looks like. Man, I feel like it needs a logo or something. We might have to do that once we're done laying it out. Leave space somewhere. Yep, you can see this piece on the bottom there. Oops. All right, I think... Yeah, I don't see anything weird. Yeah. I wish if I kept hitting the 90-degree rotation, it would keep rotating around. Hope those are big enough for the wires. They should be. If not, we can cut some off, but I think that works. Let's see. Differences. Is there like an option to turn off the black PCB? Layer colors. That's not it. Interesting. Gotta try and figure out a way. It's cool that it's black, but I wish I could get it to be like blue or something so that it would be different than the switches. All right, so that looks good. We need to figure out now where, like, because obviously we have a ton of extra space up here. We should just cut it off and bring it down, so because that would make our board cheaper, which is what we want. So I guess we just got to figure out where we want to cut it off to. Where is this? Let's see. Let's go like 10 mils up from the top of these letters. What is that? 3350, 3400. That's 50 mils up. Okay, wow. I think that's good. Maybe 3400. So how do I edit board shape? Interesting. Nope. This one needs to stay where it's at. Nope. 3040. And what we decide? Was it 3450? Yeah, let's start with that. 3040 and 3450. All right, come on. $33.50, $34.50, or 3400. Yeah, 3400. That's what it was. 3040, 3400. Okay, that's where we want it. Maybe we should just do it like this and have this weird trapezoidal board. That would be kind of funny, honestly. All right, 3,400. There we go. Is that too close to the edge? I don't think so. I think we're okay. We're cutting it close in terms of like the lettering to the edge of the board, but I think we should be fine there. I could see how that could be really annoying though. Okay. Let's just check again. 3D view looks good. Yep. Much smaller. And yeah. Looking good. It's a pretty big distance there. I'm interested to see. We should be able to fit this in the case, but we might have to use some standoffs. I don't know if there's a way I can measure distances. Doesn't look like it. All right. So now we need to place these standoffs. $142.5x. Interesting. All right, copy, paste. Nope, that's not what I wanted. I think this was happening to me last time. Like, it just wouldn't copy and paste. And I just don't know why. Yeah. it doesn't work, and I don't know why it doesn't work, but that's kind of funny actually. All right, so we're just going to have to create new pads and then just copy all of the properties. All right, so first things first, y should be 3,400 minus 140, 3,300, 3,260. X is 142.5. I'm just giving the same spacing from the edge of the board as I did down here. And then what are the other properties on this? Hole size is 125. And then size and shape 60 is 60. Hole size is 125. Okay. I need to lock this back in. Okay. And then same thing over here. $2,897.5 on the X. All right. 3,260. And then we said 125. You know, I've just realized something. You'll notice in this that we have the actual size of the pad set pretty small, but in reality, we should actually still have some of the pad, even though this isn't electrical. Like, we should have some of the pad be out and around here so that when we screw it down, the head of the screw doesn't like grind into the board. What does 130 look like? Okay, a little weird. 50 D. Does that give us enough? Maybe not. Let's try 170. 70. It's a little bigger. 190. 190. That looks better. So that gives a spot for the screw to like hang on to. Let's see here. 0.182. Outer diameter. 0.090 inner diameter. That works, okay. Yeah, I think that works. I think that's a good number. 190, okay. So I need to change that on all of these. So this will just give us a spot, some metal on the board for the screws to hit when on the heads. And it'll keep us from grinding into it and just make it sturdier. I don't know why I didn't think of that before. Okay. See how good that looks? So there's some metal there for us to put the screw on. Cool. That looks awesome. It's getting there. It's definitely getting there. I wish I could make models as good as these resistors because those look awesome. Interesting. Okay. Well, I guess now we need to actually like run all the traces. Because we have all the holes for the mounting. We have everything where it is probably going to last, so everything's locked into place. So I've never actually run traces before in this software. I assume it's under this route thing. Interactive routing. I don't know what the keyboard shortcuts and stuff for this is. But I guess let's start simple. Let's route the ground traces. Oh, that's interestingly almost perfectly diagonal. Let's see. This is always like one of the most subjective parts of a circuit board. Is just how exactly do we do it? There we go. Command is currently active and save cannot be pleased. Exit from all commands and then save. Okay. And you'll notice that the little line that was connecting these 2 points is gone because that trace is now routed. And then now actually this ground trace right here is routed to the closest point, which is right here, showing that that's where we want to connect it. You know, I don't actually know. This is a free software, so there might be an auto router. But between you and me, I personally can't stand them. But I think a lot of the decisions that auto routers make, for this, it would work fine because there's no high speed stuff. There's nothing very critical. So, I mean, we could take, you know, one of these traces and route like some laps around the board, and then it would probably still work, although it would be a little weird. But I think I personally don't find auto routers to be that effective. So, but it may not matter because I don't think that this software has it. The maker auto routes. Maybe it does. Maybe I just don't know. I'm looking it up right now because now I'm curious. Okay. In the documentation under commands, there's a thing called auto routing tools. And it is a page titled auto routing tools, last modified in 2014, and it is blank. So that was the least helpful piece of documentation I have ever seen. But I think that answers the question. That I don't think there is one. Because there doesn't seem to be any posts related to it, so I guess we are doing it by hand. So there's the answer to your question. No auto router. It doesn't exist. Okay. Yep, I agree. That's that. How's it going, Beth? Yeah, that documentation blank page was probably the funniest thing I've seen in a while. Okay. I'm just trying to think ahead. Like, oftentimes a lot of PCB routing is like you're trying to think of too much at once, and really you just got to start doing it. And then you can move things later if it looks weird. So I think I'm just going to do that. Let's go to a route. And then... Oh, good. I know it's been warmer here, and it's been great. Oh, no. Okay, that looks good. I assume I'm on the top of the board. I don't actually know. Everything is through hole, so it can be routed to the top or bottom. How do I change what layer I'm on? Nope, that was... I think I need to Google this real quick. I'm going to need to... How's your all's Tuesday going? Change route layer. Plus and minus keys on the numeric keypad. This will automatically insert a via. Interesting. Okay. Oh, what does this look like in 3D view? Oops. You can't see it because it's hidden underneath the layers. Yeah, I gotta turn this off. I gotta figure out how to make the board look better. All right. Oops. So let's go route. Let's try this real quick. If I'm routing, I hit the minus button. It's almost hump day. Yep. I'm already ready for this week to be over, as that's the usual for me. Oh, no. It still puts a via in. How can I route from the... Nope. Okay, now it's on the bottom. I don't know where... There's probably like an option on the screen here somewhere that I'm just missing. There we go. And now see, by putting one on the top and one on the bottom here, I've made it really hard to route those back. But that's okay. All right, we'll start this way then. Let's just go around this and then down here. I feel like it's going to be just a mess when I'm done, which is going to be hilarious. Because it's all like just unplanned. There we go. So that first switch is almost completely routed. All right. This one could probably just go right up here. Oh, wow. It won't actually let me route things across itself. Weird. That's kind of a cool feature, though. Let's see here. Leave a little space in case we need to cross. So that switch is routed. Probably should have done the potentiometers first, because honestly those need to be the best lines because they're going to be the noisiest. Hindsight's 20/20 though. Where does that one go? There we go. Okay, so that one's in place. Still can't see any of them in 3D view, which is kind of annoying. Wish you could see the traces. Alright. And then we got this ground here that needs to be connected. I wonder if I should just like flood it with a ground plane when I'm done. Maybe that makes more sense. And then that way there's less noise. I might do that. So something that you can do in circuit board design is you can put a basically say like fill all the empty space with an electrical plane that connects to like ground or power, and then it'll just connect everything together, kind of. It depends on, there's a lot of nuances to that, but oh good, I'm glad you like the music. I tried to pick stuff that would be calm but not like too distracting, you know. But you can put these planes in here to connect a bunch of stuff, and then it also serves to help clean up signals, because if there's ground around everything, it kind of minimizes the interference from like outside noise. Since we're not doing anything too fast, noise is not likely to matter that much, but it can if you're doing high frequency stuff or critical stuff. Let's see, I do not like moving over just a little bit there, so we're gonna do it this way. Okay, there we go. Yeah, I might do that actually. I might just delete all the ground connections. Yep. Well, actually, before I do that, let me make sure that it's possible. Okay, maker ground plane. Polygon pour. That's what it's called. That sounds right. Yep. Regularly shaped areas of the board, automatically pouring around existing objects, availability. Placed in the PCB editor, you can place it directly. All right, excellent. It exists, we can do it, so. I wonder if I can connect these to a signal, because it'd be cool if I could connect them to, like, properties to layer no net. I can connect them to a net. Oh, yeah, they're definitely getting connected to ground. And that way the screws and everything are quote-unquote grounded as well. Not really necessary in DC component and small, low voltage stuff like what this is. But if you're doing like high voltage AC straight out of the wall or something, you need to ground basically all of the metal components that could, in your design, in case something shorts, you don't accidentally shock somebody. You get in a lot of trouble and get sued if you do that. Okay. Is this top layer? It is. Perfect. This needs to connect here. All right. And then let me delete these grounds. Oh. I don't know how to delete like an entire trace. Okay, that's good. 4. Excellent. Ground. All right, so we got our inputs connected for all of our switches. So now we need to do the inputs for our potentiometers. And as far as the input, so on some of these potentiometers, we have to input high voltage. Not high voltage, but like 3.3 volts. Whoa, excuse me. What I'm going to do is put one plane on the bottom of the board that's connected to ground, and then one plane on the top of the board that's connected to power. And so I'll have a power plane and a ground plane. Actually, now that I'm saying that, it doesn't sound like the best idea, but I don't know if it would cause any problems. Let's see, ground is on this side, right? Yeah, it's down there. I don't know that that would cause any problems. Yeah, I think that'd be okay. Although I think it would just be like a bit of a waste, like not totally necessary, but I think it would be okay. All right. We may try it, and then if we don't like it, change it. All right, this one's gonna be a little weird. It's gotta work its way around. There we go. Kind of an odd path that one had to take to get there. Okay. Ground will be on that side. That's fine. The ground plane will work for that. I'm trying to decide now if I should move all of this. Yeah, I'm thinking I should try and move a lot of this stuff to the top layer and just put the ground on the bottom layer and let that take care of it. Basically run all our tracing on one side. It might look a lot cleaner that way. Yeah, I think that makes sense. All right, so I'm going to take this one out, this one out. See, this is what I'm talking about with PCB design, where it's like, it seems a little overwhelming at first because you're not trying to figure out exactly what you should do, like what methodology, but You really, in some cases, just have to start drawing it and then realize what does or does not look good and or doesn't work, and then you just go from there. Okay. So that looks good. That'll go around, and then we can delete this one. Oops. One, delete. And then connect that on the top layer. It's going to be really funny if I think I'm connecting all this stuff on the top layer and I'm actually connecting it on the bottom. Oh, I did get that positioning wrong. So which one should have been up there? I was thinking about running it around this way. Around the outside. I might still do that. Yep, that's how that's going to go. Okay. So this needs to go. And then this needs to go. Actually, it all does. Switch 3, switch 4. Okay, I think I can make this work. And then this needs to go as well. All right, and we're going to run it from here. Like right over here. It's going to look... I don't like the way that looks. I wish it would... Okay, hold on. It's not art, but it is. You know? It doesn't have to look good, but it does, kind of thing, you know? So... There we go. Oops. All right. And then this one can just come straight down here. And then this one needs to go around the outside of switch 3. So it probably actually just needs to cut through here, come around this way. And then maybe like right there. Yeah. And then switch 3 needs to come this way. Leaving a healthy amount of spacing there, way more than needed probably. All right. Okay, and then actually, I need to change this one more time. I need to change this one. To go up and over. Why? Okay. There we go. And then last, this one right here gets moved to the top layer. Okay. There we go. So if I zoom out some, everything so far is routed on the top layer, which has no actual like benefit other than It just means that the entire bottom layer is open for a ground pour, which would be good. And then we could. I'm still trying to decide if it's worth. Where's the power connect at? I need to find that. There it is. I could easily run that up and around the outside here. It's probably not even worth doing a power plane pour. Yeah, it only connects to the power in one spot. There's only one VCC. What does that look like on their schematic here? Right, because this position didn't exist. So 3.3 volts only exists in one spot. Yeah, we're just going to run that one. I'll go ahead and save that. All right, we're going to route this one. There's no point in doing a polygon pour for it. All right, we're going to go up and around the outside here because it's got to connect to all of these up top. Whoops. There we go. And then we will just go up and over. Yeah, let's do this. There we go. And then we will go straight up. Perfect. Okay. Properties, and how thick is this? 10 mils width. It's not very big. 1/100 of an inch. I mean, that's pretty thin trace. And it's running power through it. So I don't know how. It shouldn't have to put out a lot because it's just going through these potentiometers, but still. What's 50 look like? That's huge. I like that. Oops. We'll have to be a little careful here. We could be getting too close to some things. This is massive power line. It's got all these red X's on it. I wonder if that means it's having an issue. Let's try and compile the design. Alright, well I didn't get any warnings, so... Yeah, it's probably that too. Maybe 20 is better. I'm okay with the rest of them being small because they're just signal lines effectively, but this power line, because it's feeding multiple things, I want it to be a little bigger. I think there is a math to it if you're like trying to transfer a lot of power, like what the minimum, there's a formula or something for like what the minimum width can be. But we're dealing in such small increments, it's not going to matter. We could pick the smallest option and it'd still be fine. Okay. Just why does that glow red though? That's the part that I'm not getting. Optimized net. I'm not seeing any like messages or anything. I might have to come back and change that though. I don't know why these red X's are appearing. Let's make sure we're not getting too close to anything. Yeah, we're looking good. Alright, I think that looks good. Everything else is just a signal, so it can be a smaller line. I may, in the future, increase the size of these ones. The signal lines for the potentiometer, because if they're bigger, they'd have... It's not going to be whole super noticeable. They'd have a little less interference. Alright, I guess now I need to read this documentation to figure out how to do this polygon pour. PCB editor, switch to PCB editor, click on home, pour, polygon pour, which is this one. Click on the image. Okay, this pops up. Select the fill mode. Select the polygon fill mode, is what it says. I don't see something that says fill mode, but I'm assuming it means this solid. All right. Select the required net. And we want this to be ground. Oh, we want it to be on the bottom layer too. Enter your preferred name. Bottom ground plane. Okay. So this is going to be a little tricky, but I think I can do it. All right, and then I'm just going to go down until I'm at 3040 and I need to be a 0. And then over. Ah! And then do I need to go back up or can I just be done? Hey! It worked. And you can see that it's made everything extremely hard to read. So it worked great. Hold on. If I click outside. Okay, that looks better. Why is it on top? If blue is the bottom layer, or just the top layer. Okay, if I click on that, maybe it's just because I was clicked on. Yep. And so you'll note too that anywhere there's a ground, it connects. There's a bunch of connections drawn. But anything that's not ground, like this one, there's no connections. Or this empty pin. So we'll have to adjust those. But yeah, there's our ground plane. It covers everything. All right, let's change these. No net, we want them to connect to ground. Okay. And then Like that's a little key symbol that shows up when they're locked. That's cool. It's not actually connected to the ground though, which is really annoying. Is there a way to regenerate the pour? Let me go ahead and connect all of these real quick. Typically, there's a way to like rerun the computation of these polygons so that when you change things like this, you can go ahead and connect them after the fact. Man, we're getting way too much done tonight. I'm getting worried. I'm gonna run out of stuff to do. Okay, and then for the polygon options, no. Properties. Yep, polygon. Okay, if I hit OK, does it fix anything? No, it doesn't. So it's still not connected to these. Circuit maker polygon connect to via. Let me change it. Oh, okay, there's an option to repour. Hold on. Let's go back. Is there an option here where I can repour? Okay, let me Google that. Circuit maker repour polygon. Polygon actions. Set all to poured. Resize polygon, move polygon. I'm going to get this eventually. You just wait. He's poured. Okay. Hey, there it goes. It worked. Okay. So you can see now our screw mounting place here is connected via the polygon, or is connected to the ground plane. So the screws will be connected to the ground as well. And there's one last thing I wanted to do if I could. Properties, plated, locked, jumper ID net. Settings. Okay, so see how there's a cross kind of thing going here where it's connecting at these 4 points? Typically there's a setting where you can remove that and it will just connect all the way around. The reason you don't do that usually, so like down here, you wouldn't do it here because I need to solder to this via, and if you're connecting to it directly, then all that heat while I'm soldering to it is just going to dissipate into this plane. So you want to restrict how much heat can escape, and it's what's called a thermal. And so you add this thermal, this cross pattern to restrict the heat escaping while you're soldering. But we're not soldering to anything on the screw hole, so I kind of just for a good connection, especially since we're going to be tightening a screw down on this, it could possibly break traces or something. I want to see if I can get rid of the thermal. How happens if I turn this off? Nothing. let's see. Circuit maker. Thermal. Polygon connect style. Is this an option in the polygon thing? I don't want to do all of them that way. According to this documentation, yeah, okay. If that's how that's done, then I'm not going to change it. How do I get it? Hold on. Polygon connect style. I just realized that most of this documentation was last published in 2014. I wonder how useful. Solid connection with the ground plane makes sense. However, looking at design rules, it seems only possible to record one style of power plane connect foreground via. So try using solid regional layers, send it to ground. Okay, interesting. So it seems like everyone agrees online, but basically the connection style has to be the same for all of the connecting point, all the pins that are connected. So I guess we are not changing it. Okay. All right, well, that's all right. All right. Maker PCB color. Oh, interesting. So now I'm looking at how to change the color of this back to green or blue or something. People are effectively having to like hack the software to get it back. So there's a all right, hold on. View options. I'm looking for something that says like view configurations. I don't know, maybe it's just layer colors. It's not it. Let's see. Variants. Yeah, you can add a new PCB. Home. Sure, board options. Not there. So at some point, I changed it to this black, and now, like, from what I'm reading online, you can't exactly change it back. It just doesn't do it. So, and then if I go to the colors, It doesn't give me anything for the three-dimensional view. All right, where's the view configurations? Is this going to work if I type it up here? PCB standard, change view configuration. Oh, I clicked it, nothing happened. I'm going to figure this out. Eventually. View configurations. Here it is. That took me forever. Okay. Let's switch to 3D. Sorry, mask. Core. Copper. There's no like go back to defaults or anything. Oh wow, that is really blue. I can't undo it. Oops, sorry. Oh man. All right, I guess we're doing black. I don't think it's gonna show me the traces in 3D mode. It just won't do it, but that's okay. I guess next thing then, now that this is done, maybe we need to put a marking or something on it. What do y'all think? You think we should? I think we should write something on it, like the Inicus project, and then maybe the name of it as well, like MIDI controller, and then. All right. Can we add text? Yeah, we can. All right, we probably don't need to. Well, actually, heck yes, yeah. I'm trying to figure out like what we should put on it. Like, obviously, we should put the Inicus project. Obviously, we should put shoot, like what type of part it is. But like, there should be like Easter eggs too or something, you know. So there's also this thing you can do. So typically, when you put text on it, you put it in the silk screen. But there's a thing I learned, a little trick I learned a little while back, where if you want to put text on there, you can actually put it in the copper layer and then duplicate that text in the stop layer, and it effectively gives it a look of like a chrome text. You know, Godzilla wins. Spoilers, jeez. If you haven't seen the movie yet, Godzilla kills Kong. I wish I could put the logo in it. That would be really cool. I wonder if I could do that. Circuit maker, silk screen, picture. Maybe somebody knows how to do that. I'm using a DXF version. Oh. Okay. People have managed to put logo on using DXF import. I might have to look into that. All right. Well, let's put some text in here. Obviously, let's see. It's a top overlay. Not paste. Yeah, I think it's top overlay. So click on top overlay, click on text. Yep, that's right. And then properties. You can make it say a lot of different things. You want to say the Inicus project. You can do a lot of stuff with this too. All right, we need another piece of text over here. Rotation 90. Midi controller. Okay. We can drop this right here. This whole like bright blue bottom layer is actually kind of annoying. Let's see. All right, we'll hide that for the second so I can see what I'm doing. And then go ahead and lock these. Yep, looking good. All right, any other ideas for Easter eggs? Anything we should put on it? If not, I'm gonna have to come up with something. And I'm not putting Godzilla wins on it. That's sorry, but I'm not doing that one. You know, we're making this device for that one guy. I should put like 2-bit of me from the Inicus project or something like that. Yeah, that actually seems kind of like a good idea. Properties, we'll go 90. Nope. I was going to try and put a... Yeah, let's just move this one. All right. And we want to move this 90 degrees. All right, then what's the XY here? 130, 1180, 275, 1180. I think that makes sense. Actually, you know what? We're going to try something here. Hold on. Let me unlock these. I just want to try this and see if it actually works. I'm going to do that thing where I try and make it chrome. So I need to copy this. Copy. Paste. Sure. Wow, they made this about as hard as it possibly could be to use. All right. Let's make this 0 again. Put it back in the right place. And then we're going to change it just to say the Indicus project. And we're going to change the height of this to be bigger. There we go. And then just a 30. Too much. Actually, what kind of fonts do we do? Stroke or true type? That's better. What's true type? Oh, you can literally pick a font. Okay. I kind of like the stroke look. It's like the same thing that goes on the same like vectored font that goes on all PCBs. All right, and then for this, paste. I need to offset it for a second. Okay. Now we go in and change this. Top paste, top overlay, top solder. Top layer. Okay, it's all the way up at the top here. I was like, why is it not alphabetical? All right, want that to be in the top layer. Okay. Same thing for this. This to be in the top layer. Oh, I messed this one up. Properties. Top layer, okay. And then this needs to be the top. Is it the solder layer? I think it's the solder layer. top solder, top overlay, top paste. Paste is going to be for the stencil. Overlay is for the text. So it needs to be top. Yeah, I'm pretty sure top solder. Okay. Properties. Top solder. Okay. And then we need to lock this, and then we're going to go back to this one and just copy these numbers. 130, 1180. 130, 1180, and then lock it. Okay. And then same for this one. 275, 1180. So 275, 1180, and lock that. Okay, so that's in place too. And then if I go to the 3D view, oh, I think it worked. Look at this. It's the same gold color as our vias. So we basically put in some copper in the form of text, and then cut away at the top layer that was covering it, and it produces the text. I probably need to go through and verify that this is actually big enough. I think it is. It's 10 mil thickness. It should be fine. Because they're going to have to acid etch all of this away to make it work, rather than just using a printer like everything else. But the way most circuit board pricing works, this actually doesn't raise the cost at all. So I guess I will let them do that because it's not going to cost me any extra. All right. And then I'm actually going to make this one bigger. I'm going to do the same thing, size that we did with the Anarchist Project 120. Okay. Yep. There you go. That looks awesome. It's all designed. The circuit board's done, quote unquote. So I guess next time I need to figure out how to export like a 3D model. And then basically I need to spend, next time is going to be a little painful because I'm going to have to learn how to use some sort of CAD software. And I'm going to have to figure out how to import everything and line stuff up and make custom edit shapes and stuff like that. So next time is going to be some 3D modeling, which is in all of like the engineering stuff I've done, probably the thing I've done the least of. So yeah, if you know anything about it, please be there because it will help. And then I got to start figuring out what to do going forward because I'm having fun doing this, but I need to get more people involved. So I'm working on some stuff there, but if you have any ideas, please send them my way. All right, I think we're good for tonight. I think we've done everything that I wanted to do here. So thank you all for watching tonight. I really enjoyed doing this. I really enjoyed hanging out and working some more. It's cool to see this thing come to life. And I can't wait to keep going. And man, I hope soon we can order this stuff because it would be awesome to see it all put together and done. All right, well, thank you all. Have a good night, and I will see you all Thursday. Bye.